this lesson we're going to look at angles and parallel lines. When a transversal cuts across a pair of parallel lines, it creates a number of angle pairs. Many of these pairs are equal angles, while some are supplementary. That means they add to 180 degrees. I'm just going to draw a couple of pairs of parallel lines, and the lines cutting across are called transversals. So this is a transversal, and as you can see, it creates a number of angles. The first type we're going to look at are called vertically opposite angles. And as you can see, we can actually see two letter V's here pointing towards each other. Vertically opposite angles do look the same, in fact they are the same. So they're equal. The next type are called corresponding angles. This is just one example of a pair of corresponding angles. Corresponding angles have the same relative position. So if you imagine this was the deck of the QE2 and this was the upper deck, somebody might be sitting here on a chair and somebody on the deck below might be sitting on a chair, and you can see they're in the same relative position, just that one's above the other, and so they are the same angle. So corresponding angles occur here and here. There are other examples of corresponding angles, for example in this region here and also in this region here. Another type are called alternate angles. Alternate angles are on alternate or different sides of the transversal. This angle here is to the left, this angle here is to the right of the transversal. Alternate angles tend to form the letter Z, if you can see as I trace out. They could also trace out the letter S. So this angle up in here and this angle in here would also be alternate. And of course, if I didn't mention already, alternate angles are equal. Now the other angle pair we're interested in here and here are called co-interior angles. And if you think of the interior of a cave, if you were walking into that cave and there was a bear inside and you decided, no, I don't think I'll stay here, I think I'll turn around and go straight back out the other way, you've actually turned through a 180 degrees turn. So this angle here, you've turned, and you've turned further through this angle here to go out in the opposite direction. So these two angles together must form a 180 degree angle. Let's look at some examples now, and let's introduce a bit of algebra. Looking at our first example down here, we have some vertically opposite angles. Now that we know they're equal, so we can write an equation that says that 2x minus 120 must be equal to 30. To solve that equation, we need to take that minus 120 across to the right hand side of the equation, making it positive 120. And so we get 2x equals 30 plus 120, so 2x is 150, and then dividing both sides by 2 to make x the subject, we have x is 75 degrees. The next example, we've got two angles which are co-interior. That means they must add to 180. So we add up the 2x plus 50 and the 3x plus 55 and put it equal to 180. We can simplify the left hand side of that equation. The 2x and the 3x make 5x, and here the 50 and the 55 make 105. So 5x plus 105 must equal 180. Let's take that positive 105 across to the right hand side of the equation. So it's now 5x equals 180 minus 105, which is 75. The last thing to do is to divide both sides by 5, and we get x equals 15.